Hey, welcome back to the Adventures of Blink. I am, of course, Blink, and you can find me on GitHub right here. Now, in addition to that, you'll also notice down in the description there are some links to the blog where you can see a written version of this video. If you haven't encountered it that way before, maybe that's more your bag. Try it out. But since you're here on the video, I want to make sure that you take a minute to like, subscribe, and click the notification bell. Those simple steps will make sure that you stay attached as we go through the rest of this season. And I don't want you to miss out on any episodes, because I hope that by the time we get done, you're going to have a working product that you can actually build from, that you can play around with. I like it when we can get something out of what we do and not just spend time learning, but actually have something tangible to show for it. So what are we up to? Let's recap real quick. We started by talking about Docker Desktop and figuring out how to run containers locally. Then we built a Mongo container, and so now we've got a database for our application to use. We also used Docker Compose as a way to orchestrate the containers that we're going to build throughout the app, so that they all start up in the proper order, that they all work together, they all know how to communicate easily. So we've been playing with that as just a way to spin up our environment all in one command. And then, of course, last week we built a Flask API, and we're using that as an interface to the database so that the front-end application doesn't have to have a whole bunch of database code built into it. It can just make calls to an HTTP URL and get back data that it needs. So today, we're going to start on that front-end application. We're building it out, but the technique that I wanted to experiment with is called TDD, Test-Driven Development. Now, if you haven't done that before, that means you actually write your unit tests first. You write out how the app ought to function, and once you've created that as a framework, you start writing the code of your application until you pass the tests. It's a little bit of a brain bender at first, but I promise it gets really easy, and it's really cool after you see it happen. It's just a different way of thinking, and I think it's really a valuable way of thinking, because it gives you some really cool benefits that we'll hopefully explore as we go through this. Should we just go on ahead and get right in? Okay, so you can see our project here on the left, and there's several things in here you'll probably recognize. There's a database and a DB API, and of course our Docker Compose YAML that we've looked at. And I've been building a git ignore, which I'm not going to talk about that today, but that's coming soon. We're going to talk about how to interact with GitHub and use Git effectively. But that's beside the point. There's also our env file. Those are things that have existed in our project, and we're actually not going to touch any of those today. Our focus is this new folder that I've created called Hangman. Hangman is the front-end application. So if you think back to the structure of our app, we had the database, and then we had the API layer sort of in the middle, and then we have the front-end application. And that front-end application is what we're going to build on today. So if I open this up, I've got another Hangman folder inside here where that's actually going to be the code for the application that lives in there. So this is the stuff that runs the game and makes it function the way that you and I would experience it as a video game. That's not where we're actually going to start, though, because we're going to focus on the tests first. Tests are, of course, it's a folder where you're going to keep track of all of your unit testing, all of your integration testing, all of those automated tests that you want to build to know whether your application succeeds or not. If you're not familiar with this concept, automated testing of your code is actually a really powerful tool because it helps you document what your application does without having to write a bunch of docs. You can hand the tests to a developer, and they can see what your application is expected to do, like what behaviors it's expected to have. So let's see if we can dig into testgame.py and get a taste for what's going on in there. I'm going to walk you through this code. It's already written, of course, so we're not going to do any live coding. but I wanted to kind of just help you understand what it is that we're doing. So the first thing we have to do is we're going to import the PyTest library. PyTest is a unit testing library. There are several you can pick from. If you have, holy war preferences, feel free to yell at me in the comments. But I'm focusing on PyTest just because I've found it easy to use and easy to be able to teach how it works. Then the other thing we're going to do is from hangman.game import hangman. Now this is a fun thing to start with because we don't actually have a hangman.game and it doesn't have anything inside it because it doesn't exist. Now it does because I've already gotten to the end of this process, but that's actually sort of the starting point for what unit testing is about when you're doing TDD. You're going to write what you expect to exist, and then later on you're going to fulfill those expectations. So we're starting off and we're saying in the game file, we're going to have a hangman class. And no, it does not exist today, but it needs to, and that's something that we expect to be there. So the next thing we're going to do is create something called a fixture. When you're unit testing with PyTest, you can use fixtures as a way to make it easy to share, set up, and tear down code. So if you think about running a unit test, what you actually have to do is create stuff that uses your code, and then you run the tests to make sure you get the expected outputs, and then you have to tear it all down afterward. So in this case, it's the hangman game that we're going to be creating. So I define a new game function here and I annotate it as a fixture with this line 10. And all it's going to do is call the class and it's going to instantiate a hangman game. And it's going to use the word Python as my phrase. So if you think about playing hangman, you have to give it a phrase and it puts it up there with blanks and then you have to guess the letters to fill in the blanks. So that's how we establish the word. Again, we're starting to see how the class is going to function because when you instantiate the class, you are required to pass in the word or phrase that you're going to use. I could very easily make this say something like that, Python space game. And so now I have a different board that's been created. But that's the function, that's the features that I want to use within the class. I know that I'm going to instantiate it and I'm going to pass in that value at the beginning. So the next thing down is our first test. Now this test is validating that the game starts up successfully. When you create a new game, is it going to be in the state that we expect? Well, what state do we expect? Well, the first thing you have to do is you call the game equals new game. So this is using that fixture that was up above, new game, to create a variable that holds our hangman game. Now, once we've done that, we can start asking that game to tell us things that we care about in order to validate whether it's behaving the way we expect. So when the game first starts, we expect to have 6 lives remaining. When the game first starts, we expect the display word to be 5 underscores. P-Y-T-H, I can't count, 6 underscores. P-Y-T-H-O-N. The next thing we're going to do is have an array of letters that have already been guessed. This is important because we want to display that on the screen and say, hey, here's the letters you've used. So we'll need to track what letters have already been guessed. And it should be empty when we start. Then we're going to have the game over. And so this is just a variable that says, has the game ended? Have they either run out of lives or have they solved the puzzle? So those are the initial game state features that we want to have available to us. So the next test we're going to write is actually the test that validates whether we guessed correctly, or it's going to validate the conditions under which we have guessed correctly. So we instantiate the new game, and remember we're using Python as the word still. And the first thing we do after we've created the game is we issue a command to guess the letter P. Now, P is the first letter in Python, and so we're expecting this to come back happily, like this is a correct guess. It's a letter that we found in the final like hidden word. So we're going to return that to a result, and we're validating that the result is true. So that means that the guess method should respond with a Boolean that says this is true. Or it should respond this is false if it doesn't find it. But guess is going to work both ways. In this case, we're only testing the correct guess. We'll get to the incorrect one. Actually, you can see if you look ahead there, we'll get to that shortly. But what are the other things that we would validate? Well, we would want to update the way the word is displayed. So we want to uncover the P, but leave the rest of the letters filled in, or hidden, I should say. So yes, it starts with Python. We guessed the letter P. We can now see that P is the first letter in the word, but we don't know the rest of the letters because we haven't guessed them yet. And then we also want to make sure that the guessed letters variable now contains P as an item. And that way we have record of what all's been guessed as we go. But those are the conditions that we would expect to be true. If you make a guess and it's successful, then we would see it behave in this way. Now let's test an incorrect guess. So we start off the same way. We build the game. We fill it with the word Python, but we're going to, in this case, guess the letter X, which is not a letter in the word Python. And so because it's not, we'll get back a false. We should see that the lives, we went from a new game, the lives went down to 5, and the guessed letters still contain the letter that was guessed. Now we're going to test multiple incorrect guesses because it's important to see the different values there that might be treated differently. So in the case of direct or testing multiple incorrect guesses, we're going to guess X and Z. Now this is going to take the new game lives down to 4 because remember we started at 6. So now we see that we've changed the value differently. And then we're going to assert that X and Z both appear in that list of guessed letters. The next test we're going to do is to test whether the game has been won. So we're going to start the new game, and then we're going to guess all the letters in order. And if the game comes back, if game.isWon responds as yes, this is true, then we know that we have successfully met the conditions. And we're going to test two different things. So you have is won and you have is over. So there's two ways the game could be over. I could win or I could lose. And we want to test both of those conditions to say, yes, the game is over and I won. Now we got to do the same thing with lost. So in this case, we're just going to test A, B, C, D, E, F, which conveniently don't appear in Python at all. And so that takes our remaining lives down to 0. We should see that the game is over, but it is not won. And then we're going to test a duplicate guess scenario. So if I guess the letter P and then I guess the letter P again, what should happen? Well, we're going to take the simple approach that says we're not going to penalize you for that. So if you guess the letter P, which is in the word first, then we know that didn't affect the number of lives, so we should still be at 6. When you guess it the second time, we should also see that the remaining lives are at 6, and that the guessed letters only contain one letter P. So those are our sort of guardrails as we're building this game. We know that we want it to respond in these ways. And this is not a comprehensive list of tests, but this should be enough to get started with. Now we've written this thing, and we can run our test and find that it fails right out of the gate because none of this other code exists, right? This is by no means a comprehensive list of the unit tests required for the game Hangman. We will probably encounter more as we build things, and we'll go, oh, we should actually have something that tests that code. But this is enough to get us started because it gives us the basic rules of the game. Now, I can run these tests right away. I can just type PyTest down here, and you'll see I get errors. And there's a ton of things wrong. It's complaining that there's no module named hangman that contains the game. So remember at the top and up here you can see hangman, and I don't know why it did that. There we go. So it's complaining that it can't find the game .py file. Well, as you can see, I've renamed that to test so that we could experiment here. But let's take a look at what it takes to build that out now. The first thing we know is that we're going to have to create the class hangman. Okay? So if I rename this to game.py again, now that completes up there. Let's go look at what's in this code and take a quick look at how that behaves. All right, so now we're ready to look at how the class hangman actually starts to be implemented. And this does not complete all of our tests, but it's enough for you to see kind of the process that you go through. So the first time you run PyTest, you're going to get a failure that says, I can't find the module. And so you create the module. Here's a game.py. Then it will complain, hey, I can't find the class hangman. And that's what we're doing now. So in order to define the hangman class, I need a constructor, and I know from the tests that I have to pass in the word or the phrase, whatever you want to call it, but I'm passing that value into the constructor. So when I call to instantiate a new hangman game, it's going to ask for that word to be there. And so that's what word is here. Okay? Then once we have those things in place, we can start adding variables. So I'm defining remaining lives, guessed letters, is over, is one, and then I pull the word in, but when I pull it in, I'm converting everything to caps because I want the game not to function around the idea of case sensitivity. I want it to just be focused on capital letters. So sure, if you happen to type it in manually and say this is the puzzle I want, we're going to convert all those letters so that everything's in caps and we don't have to worry about case sensitive guesses later on. Now, another thing that's of note here, sort of an extra that I've added, is that I've made each of these member variables protected. That's what the little underscore before the variable name means. What this means is you can't access remaining lives directly from the outside. And that's a safety mechanism for the game because what it does is prevent somebody from being able to alter that and say, I have 160 lives or whatever they want to say. Or to put, new guest letters in there or something like that. And find some way to subvert the logic of the game and win, right? So we're protecting those variables by saying only things inside of the hangman class are allowed to edit them. Now that's important in things that aren't, silly little video games. If you're writing production code, you want to make sure that your data is protected where it can't be altered in ways that you don't expect. So that's what we're going to do, and we'll talk through exactly how that works next. The last thing that I do in here is I have a display word, and it's going to be calculated down below. But that's another thing to note, that you actually have the ability to do that in your constructor and use not only a protected variable, but I can use protected methods. So calculate display word is not something that you can call from outside of this class. In order to calculate the display word, you have to be inside of hangman or be a subclass of it. Interesting little side note. Now moving on, I said that I couldn't touch these variables from the outside, but that's a problem because I can't get the values out of them either, can I? So if you annotate a method with this at property, this gives you the ability to reference those things in this manner. So remaining lives is protected. I can't use it outside of the class, but I can return it from this remaining lives method that I've declared as a property. And I did that for all of those protected variables. So each one of them now has the ability to return its value where somebody can see what it is. Now this is cool because that means they can't change the value. They have to just read it. They can't write to it. So I get to control, as the programmer, who's allowed to make edits to these variables and who's not. Now, the last method that I've built here is to calculate the display word. And this is not fully complete. It's just the beginning stages of it. So the first thing that we wanted to do was to return a regular expression where if it finds a letter or a number, it's going to replace it with an underscore. Now, I'm not going to teach you about regex today. Suffice to know that re.sub will give you the ability to do this if you ever figure out the regular expression syntax. Regular expressions are a terrifying thing, and just know that if you're using them, use them with a healthy dose of respect. They can do some amazing things, but they are scary to try to debug. So keep it as simple as possible. Long and short, this is currently set to return the word, but with all of the letters replaced as underscores. So this is how you get from, for example, Python to a long underscore. And that's what's going to return. If you would put Python in as word, then it's going to return 6 underscores like that. Okay, so now we have some of the game code in place. Let's try running PyTest again and see how things look. Look at that. I see a little bit of green. We actually passed our first test. And so if you go back to the test game, the one that's passing is this very first one that says test the initial game state, because that's what we've defined so far. You notice there's no logic in here for how to play Hangman yet. We haven't written the guess method, for instance. And so what we're seeing, as you look through the errors on the failed test, it's now telling us what we have to build next. The Hangman object has no attribute guess. Well, we're going to need that, and it says it multiple times because that's the thing that's holding us up. So none of our other tests can pass until we've implemented the guess method. This is how TDD works in your favor, because it's going to focus you on what the most important thing is. Yes, I have 6 failing tests right now, but every one of them moves forward if I implement the guess method next. And so that's the way we start thinking of what's important for me to write. Like, what code should I be working on next? Now, another feature of TDD that's really important is that it gives you the ability to minimize the amount of code that you write, because I'm not getting distracted by all the other potential possibilities. I can focus on exactly what I need to pass this test. And later on, we're going to see that sometimes you write code and you fail a test, and the answer is not to fix the code, but to fix the test, because maybe you need to change the design of what you're doing. But that's a decision you can make in flight. And of course, we can continue to add tests as we figure out what other constraints should be along the way. All right, so there you have it. There's our first foray into TDD. We've actually written some tests, blind tests, and seen them fail, and then we've written the code that helps us start to pass those tests. Now, you're probably thinking this could take a very long time because Hangman is a complicated little game to figure out. There's a lot of rules you have to account for. I'm not going to write the entire game live on an episode. I'm probably going to push most of the game code as sort of like in between episode pushes. I don't want us to get bogged down in writing a bunch of Python. I'm kind of presuming that you as the audience have already written some Python, and that's not going to be anything brand new or groundbreaking. I'm going to pause in a few places that are really interesting because of techniques I want to try. But generally speaking, we're not going to devote this time to just programming. I want to talk about the other things. So look for pushes to go up to the GitHub repo with the game code along the way as I get that finished up. I do anticipate, of course, having the entire thing finished by the time we get through the season. But the things we're going to focus on in episodes are going to be how to use tooling and how to use techniques to achieve more. So Next week, I think we're going to dig into the use of GitHub. If you haven't actually done a lot of source control work before, I want to introduce you to some features, and one of the things that we'll look at is actually the GitHub Actions, which allow you to run tests automatically when you submit your code into GitHub. Some interesting things to play around with. But we'll learn lots of little tips and tricks that kind of help the beginning developer as they experiment with tools in that way. So that wraps it up for episode 4. I hope you're having as much fun as I am with this, and I hope you're figuring out some new interesting techniques that maybe you haven't tried before. I look forward to hearing from you. I look forward to seeing you around, and I can't wait to see what kind of things you build. Y'all take care.